Hello students, welcome back. We did all the theory necessary for binary operations. Now let's consider some computational example. I'll have some homework problems too, but this one's looked particularly worthy. One way to define a binary operation for a finite set is to define through a table like this. We call it binary operation table. Here in this case, let's consider a set of 5 elements A, B, C, D, E. And this table defines like this. Ith row star jth column is ij entry. Does it make sense? Well, going through a couple of example problems will help you. So let's go ahead and do that. Find A star B and B star A star B. So ith row, jth column. So A row is this. Among those, where's B? This column. So this row, this column, there you go. A star B is B. Make sense? Basically, you're doing this. So A row is here, and B row is there, and then, okay, this one here. So thick, you can't read anything like this. Let's do this one more time. B star A, what is it? So B row is here, that's ith row, and jth column, so A column is here, and alright, that's also B. That's how you do it. How about the next problem? Well, I just showed you how, so go ahead and do this. Stop the playback and find out on your own. Did you get it? Let's see. C, and then D right here, so that's B. D star C is, let's see, D, and then C, okay, that too is B. Okay, next question. Is this operation commutative? So x star y and y star x are always the same? Well, it looks like it's true here and there, but is that true for everything? Please check. I throw jth column, that's gonna give you x star y, then how'd you get y star x? J through I column, make sense? So I through j column versus j through ith column. So somewhere around here or around there, we have to have symmetry if you have commutativity. So do you have symmetry with respect to this principal diagonal? So we have this diagonal, and we have symmetry. Everything up here falls down here. Well, I found one entry that doesn't behave well right here. Those two highlighted in red, otherwise all symmetric. Do you agree? So x star y and y star x are the same for everything except for this pair. Does it make sense? Well, let me open up the answer key here. Oops. Yeah. So B star E is C. B star E is C right here. Let me highlight this in red. And E star B is B. And look at these highlighted, they're different. So this operation is not commutative. This binary operation is not commutative. The answer is no. And we found out the example, the counterexample. Without the example, you're not going to get credit. So you have to prove it. You have to prove no. That means you have to get a counterexample. And right here, we got it. Oops, wrong key. Sorry about that. So the answer is no, but you have to prove it. And here's the proof. Oh, it was wrong cell, excuse me. This and that. Okay, next. Is the operation associative? That is, x star y, that quantity star z, and x star, parenthesis open, y star z, are they always equal? That's the question. And the answer is no. I accidentally opened up and showed you the answer briefly. That's one reason I'm confessing this easily, yes. But there's another reason. If this is true, how are you going to check? Let's see, how many x, y, z triples that you have to find out and check? And I mean, x, there are 5 choices for x, 5 choices for y, and 5 choices for z. So we have 5 to the third power, which is 125 choices to check. And then we have to consider left and right for parentheses. So you have to check 250 possibilities to check. And if they're all true, then you can say this operation is associative. Does it make sense as a problem? It doesn't make any sense to me. I mean, for a much smaller set, okay, maybe I can write that kind of problem, but for this kind of problem, it does not make any sense. It's got to be false, and there got to be an example, and your job is to find that. So find a triple, x, y, and z, so that this fails. There may be multiple, but at least there goes one. So B star CD, what is CD? C star D, so that's B, right? So this one, as I highlighted in blue, so this is B, and then B star B, what is B star B? And that's C. So we get C as an answer. Okay, how about this? B star C. So B star C, and that's A. So that's A. And then A star D. A star D, that's D. And then we got two different elements, C and D. These two are different. There may be other triple, but at least I found these three. Next, is there an identity element? That is there an element I so that that's the question. So I star x, x star I, they're all the same and just stays as x. Is there an element like that? Did you find it? Stop the playback and find it if you want. Well, you must have by now. These are all the same. All the same. So A is the identity. A is the identity. You can check it. All the same A, B, C, D, E. All the same A, B, C, D, E. See, A star A is A star B, B star A, they're both B, 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 and then C, C, D, D, and so on. Yes, A is the identity element. Now that we have yes for the identity, let's go to the next question. Does every element, they're not person, does every element has an inverse element? That is, for each x, is there y so that x star y and also y star x commutatively equal to the identity? And identity, we found out, identity is A. So for any x, can we find such a y? Well, this is not as bad as checking for the associativity, because let's see, how many times do you have to check? A, B, C, D, E, and A is already an identity, so no problem. So we have to check those for B, C, D, and E. So I have to check it for 4 times. So it's not like checking 250. So checking 4 times. So it is doable. Still, checking all 4 of them and coming up with yes versus finding one counterexample so that no, which one will make more sense as a problem if you're writing a problem as a textbook author. Of course, it's the latter. So here we go. There got to be an example. And yeah, I found one counterexample. There may be many more, but I found one, so I stopped there. D has no inverse. Let's see, let's go to D and look at this row, no A. So D times something equals A never happens. As a matter of fact, everything else I think has an inverse. Let's see, E, yeah, A show up here, A show up there for C, A show up there, A show up there for A, so yeah, okay. For, yeah, did I say there may be more? I take it back. Only D. D has no inverse. Everything else has inverse. Okay, that's it.